Okay, so let's look at some probability examples using a contingency table. So we're going to go through all the possibilities, the ands, the ors, the conditionals. So let's start with a contingency table, and we have various age groups and whether or not these people, how many people use social media or don't use social media. So if we want to find the probability that a person uses social media, so let's remember probability is the number of total number of outcomes divided into the number of favorable outcomes. And favorable doesn't always mean good or bad, it just means what we're looking for, right? We're looking for people who do not use social media. Well, according to the table, we have 192 who don't use social media out of 530 surveyed. So we'll divide this, and generally it's good to put three significant figures. So we can simply divide that out and give us 362. Very similarly, for 35 to 44 years of age, we see that 125 people meet that criteria out of the 530. And that's 236, or 0.236. Okay, so now let's go into compound events. Is 45 or older or uses social media? So we're going to use the addition rule. And because these events are not disjoint, in other words, a person can be 45 or older and use social media. We see it right here. So they're not disjoint. Therefore, we still have to subtract the probability 45 plus and use a social media. If you think of it as a Venn diagram, if we add up all the people who use social media and all the people who are 45 plus, you see what happens. This middle, this and area is shaded in twice. So we subtract one of them to compensate. So probability that someone is 45 or older. So we have, that's actually made of two columns, right? That's 140 plus 115. So that's going to give us 255 out of the 530. How many use social media? Well, that's the 338. Now, 45 plus and use social media, well, that's the area we just boxed in earlier. That's 83 plus 49, so that will give us 132 that we need to subtract. And when we add all these numbers up, 255 plus 338 minus 132, and we get 461. And we can do that division. It gives us about 0.870. Realize another way we could approach this is just by looking at the table. So let me just erase what we've done already. 45 or older. Well, if 45 or older, okay, all 45 people 45 or older, we're going to use these 4 cells. Now, how many use social media? Well, that's going to be these 4. And we see that the 83 and the 49 were circled twice. So we need to subtract those numbers to get our result. And as a matter of fact, if we hadn't subtracted it, we would have gotten 255, 338. We would have gotten 593 out of 530, a probability greater than 1, and that's not possible. So that by itself might give us a hint that something was wrong. Okay. 35 to 44 and uses social media. Okay, so there's a couple of ways we can tackle this. First, I'm going to just use the table. That's actually the simplest way to do it, because how many people are 35 to 44 and use social media? It comes down to only that cell. So 89 out of 530, and we're done. But I want to do this one other way just to make a point about independent and dependent events. You see, we can use the and, when you're computing and probabilities, you want to use the multiplication rule, right? And it depends whether or not those events are dependent or independent in terms of which formula you use. Now, we know that 35 to 44 and social media, well, it might seem that we can use 35 to 44 and multiply the probabilities, because that's what we do when we find and. But this is not going to get us the correct answer. Let's see, we got 35 to 44, that's 125 out of 530. And probability of social media, 338 out of 530. We'll get pretty close, but this is not going to be the correct answer. We'll see why in a moment. 125 times 338 divided by 530 squared is going to give us 150. Now, it's close, but it's not exact. They should match exactly. So what went wrong? The answer is that by using this formula, we assumed that 35 to 44 and social media are independent events. But as we can see from the table, the probability of using social media, 89 out of 125 versus 83 out of 140, these are different probabilities. So whether or not a person uses social media does depend on their age range. Because these are dependent events, we can't use this formula. That's why we got the wrong answer. What we would want to do if we're going to use the formula is we would have to use the formula for dependent events. So it's going to be, let's put it this way, social media and 35 to 44. So we're going to use probability of social media times probability of 35 to 44 given social media. We have to include that conditional probability if we're going to use the multiplication rule. So probability of social media is 338 out of 338. 338 out of 530. And then given social media, so all the people who use social media, how many of them are 35 to 44? That's the 89. So you see what happens here. The 338s cancel, and we're left with 89 out of 530. As a matter of fact, we don't need to divide that. That's the same result we got earlier. So that's why simply multiplying these probabilities will not work in this case when you have dependent events. Okay, speaking of conditional probability, find the probability that someone does not use social media given they're 55 or older. So we have to be more careful with this case. So we want the number who are 55 or older and number who are social media and 55 or older. So in other words, our denominator is not going to be out of 530 because the 530 is the entire population, or the entire sample. How many are 55 or older? That's only 115. Of those 115, how many use social media? Oh, it does not use social media, right? So 66 do not use social media. So don't take this out of 530. That's going to be a problem. You have to make sure what your total number of favorable outcomes is. I'm not saying that not using social media is favorable. And again, favorable, I mean what we're looking to study. And so we can divide that and get 574. So this is kind of a way of saying that 57% of those 55 and up, according to our survey, do not use social media. Okay, this last one's going to be a little tougher, but let's kind of think about this. If 3 55 and older subjects are randomly selected, what is the probability that at least one of them uses social media? Okay, so let's define some events here, or some variables. X, let's let X be the number of social media users out of 3 subjects, 355 plus subjects. Okay. So X, in terms of the sample space, can have 0, 1, 2, or 3. Those are the 4 possible values of X, because you have to, it has to be at least 0, right? And we can't have more than 3 because there's only 3 subjects selected. So here's what we're trying to find. We're trying to find the probability that X is at least 1. Well, this is going to be difficult to find directly, but the good news is we don't have to find it directly. Because let's think about exhaustive events. I'm going to finish writing this out, and hopefully you'll see the relationship here. How many of those 3 use social media? Well, it's either 0 or greater than 0. Either 0 or greater than 0. You can't have both. These are disjoint because they can't both be true, and they're exhaustive events, so they have to make up all of the possibilities. They have to add up to 1. So the X is greater than 1. That's what we're actually trying to find. So we can just, probabilities are numbers, so we can subtract this from both sides. And what we'll end up with is the probability of at least 1 is simply equal to 1 minus the probability that no one uses social media. So that's what we have to find next. This is our next goal. What is that probability? Well, let's assume that whether or not someone uses social media is independent. So when the first person uses social media, the second person uses it, the third person uses it, we're going to assume those are independent. And if they're independent, then finding an AND probability is very easy. So in other words, we want to find the probability that all 3 people do not use social media. Let me get this better. Do not. So we can look at this as the first person doesn't use it, and the second person doesn't use it, and the third person doesn't use that. Okay, so of 55 or older, let's first social media given 55 plus. That's what we want to find initially. So that's going to be 49 out of 115. So that's 426. But that's not what we're looking for. We're looking for the probability that a person does not use social media given 55 plus. Well, those are complements. So it has to add up to 1. So 1 minus 0.426, and we'll get 0.574. So this is the probability that a given person does not use social media of those 55 plus. So we want to find the probability that all 3 people don't use it. Well, if they're independent, remember, if independent probabilities, you want to find an AND for independent, you can keep multiplying forever. So it's going to be 574 to the 3rd power, because you want to take 574 times 574 times 574. They're all independent. If we do that, and we take 574 to the 3rd power, we get 0.1891. So this is the probability that none of those three people use social media. So we can take that and plug it in here. That's the probability that x equals 0. So our final answer is simply going to be 1 minus none. 1 minus no one uses it, so that's 0.189. And therefore, simply subtract that from 1, and our answer is 0.811. So 81% probability that at least one of the 55 plus uses social media. Okay, that wraps up the first part here. We've gone through a lot of the rules for probability. One thing that I would suggest, and there are a lot of formulas when we talk about probability. The formulas are generally derived not using some fancy mathematics. The derivation for these formulas usually is either just straight logic or by using a Venn diagram or a table. So my suggestion is, if you get the formulas mixed up, try using a diagram. Try using a contingency table. Try using a Venn diagram like we used up here. So it's not all about formula memorization. I don't want you to come across with that impression. It's about just we could have gotten any of these answers without formulas whatsoever, just by looking at the relevant cells over the total possible outcomes. Okay, I'm going to do one more video after that, and that involves building a contingency table given just probability.